What did you want to learn about today? Composite functions? Well, you're in luck. That's exactly what this video is about. Welcome to Math Bytes. I'm Allison, and today we're talking about composite functions. The composition of two functions is a way of combining them. You use the output of one function as the input for the other function. Let's do notation first. The composition of two functions is denoted by f circle g. You put that little open circle in between them. And at a particular point x, we get f of g of x. That's how you read it. Now, you'll note that the function that's listed first, in this case f, goes on the outside of the brackets. And the function that's listed second, in this case g, goes on the inside of the brackets. Let's do an example, and this will make a lot more sense. Okay, let's look at an example. I have two functions here. F of x is equal to 3x minus 1, and g of x is equal to x squared plus 2. Now, if I wanted to find f at a particular value, let's say at 4, f of 4 would be found by putting in 4 wherever I see an x in my function. So that would be 3 times 4 minus 1. 3 times 4 is 12. 12 minus 1 is 11. So f of 4 is equal to 11. Okay, so all I did was put in 4 anywhere I saw an x in my function. So if I want to find f of g of x, what I do is everywhere I see an x in my function f, I put in the function g. Now, the function g is x squared plus 2. So to find f of g of x, I'm going to put in x squared plus 2 everywhere that I see an x in my function f. So that would give me 3 times x squared plus 2 minus 1. Now I just do some algebra and distribute my 3 through, and I get 3x squared plus 6 minus 1, which is equal to 3x squared plus 5. So all I did was, wherever I saw an x in f, I put in the function g of x, and that gives me the composite function f of g of x. Okay, I've got my same two functions up here. F of x is equal to 3x minus 1, and g of x is equal to x squared plus 2. Now let's go the other way. Let's find g of f of x. So everywhere I see an x in my function g, I'm going to put in the function f of x. Okay, so that gives me 3x minus 1 squared plus 2. In g of x, I had x squared plus 2. Well, now I replace that with f, which is 3x minus 1. So I get 3x minus 1 squared plus 2. Now we're back to algebra. So I have 3x minus 1 times 3x minus 1 plus 2. Multiplying out, I get 9x squared minus 6x plus 1 plus 2. So 9x squared minus 6x plus 3. This is the composite function g of f of x. You can evaluate composite functions at specific points, just the way you can evaluate any function at a specific point. So let's take a look at another example. In this case, f of x is equal to 4x squared plus x, and g of x is equal to negative 2x. Okay, so first let's find f of g of x. So everywhere I see an x in f of x, I'm going to substitute g of x, which is negative 2x. Okay, so substituting my x's with negative 2x, I get 4 times negative 2x squared, that quantity squared, plus negative 2x. Now I'm down to the algebra. So that gives me 4 times 4x squared plus negative 2x. Multiplying, I get 16x squared minus 2x. So f of g of x is 16x squared minus 2x. Now, suppose I want to find f of g of 3. Now it's just like any function. Anywhere you see an x, just put in a 3. So that would give me 16 times 3 squared minus 2 times 3. I'm just replacing x with 3. And multiplying, I get 16 times 9 minus 6. 16 times 9 is 144, minus 6 is 138. So once you have your composite function, you can evaluate it at any point in its domain simply by plugging that value in for x. You know, sometimes I think the notation makes composite functions look worse than they are. So don't let that notation intimidate you. If you can replace x with a value in a regular function, you can figure out a composite function. So give it some practice and you'll get comfortable with it. That's it for this episode of Math Bytes. If you like our videos, why don't you go ahead and subscribe to our channel? And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.